So in this video I want to talk about Euler's equation, which basically expresses complex numbers in exponential form. And as you can see here, cosine of theta plus j sine of theta is equal to e to the power of j theta. And similarly, cosine of theta minus j sine of theta is equal to e raised to the negative j theta. And in the FE Review Handbook, this can be found in the mathematics section under Euler's identity. So let's do an example. So it says, find square root of j in rectangular form, where rectangular form is given here, x plus jy. So the first thing I would do is to figure out where j lies on the coordinate axis for imaginary numbers. So just to remind you, on the horizontal axis is the real axis, and the vertical axis is the imaginary axis. And j on this coordinate axis would lie right here, because the coefficient is 1, is implied 1, and there is no real term which would generally come in front here. It's just 0 plus 1j. So therefore the point we're looking at is this point right here, and this point has an angle of 90 degrees, or pi over 2 radians. And another piece of information we can get out of this is that the radius equals 1. And this is pretty easy to see because it's only 1 unit, and that's the distance from the origin. So using this information, we can plug it into this first form of the equation. So cosine of our angle is pi over 2 plus j times sine of pi over 2 is equal to e to the j times pi over 2. So this equals j. But we want to find square root of j. So basically we just have to take the square root of this left-hand side, or both sides. So then we would get the quantity cosine pi over 2 plus j times the sine of pi over 2 to the 1/2 power equals e to the j pi over 2 to the 1/2 power. And this equals square root of j. So I did a video earlier on how to simplify, or how to take the exponential of a complex number, and basically that's outlined under the polar coordinate system. There's an equation right here. This is also known as de Moivre's formula, or de Moivre's theorem. So we're going to apply this formula to the left-hand side of the equation. So what happens is the radius is 1, so we don't have to worry about the radius. But basically this exponent gets multiplied into both of these angles. So if we simplify, we would get cosine of 1/2 times pi over 2 plus j times sine of 1/2 times pi over 2. This equals e, and of course when you have an exponent raised to an exponent, you just multiply these two terms. So that will be j times pi over 4, and that's still equal square root of j. So if we simplify the left-hand side, cosine of this becomes pi over 4, and cosine of pi over 4 is square root of 2 over 2 plus j times sine of this angle is also pi over 4. So sine of pi over 4 is also square root of 2 over 2. And this equals square root of j. And this is our rectangular form. So let's do another example. So example 2. In this one, we're asked to find 5j squared in rectangular form. So I would take the same approach as example 1, and since we already found what j was, we can use that to manipulate what we're trying to find here. So we know that j equals e to the j times pi over 4 equals cosine of pi over 2 plus j times sine of pi over 2. And I would leave it in terms of cosine and sine, because when we apply this exponent here, it's going to get multiplied into the angle. So in order to make our life easier, I would leave it in terms of cosine and sine before doing any simplifications. So from here, we can, on both sides, multiply by 5 and then and then raise it to the second power. So multiply both sides by 5, so it would be 5 times e to the j times pi over 4 raised to the second power, which equals 5 times cosine of pi over 2 plus j times sine of pi over 2, and this quantity squared. So, as you can see in the FE Review Handbook, this exponent 2 gets applied to our radius and then gets multiplied into the angle. And if this doesn't make sense, I have another video where I do another example of this, but I'm just following the formula verbatim. So when you have a complex number in the form r times cosine theta plus j sine of theta, and this whole quantity is raised to some power n, this equals r to the n times cosine to the n theta plus j times sine n theta. So here, this is going to end up being 5 squared times cosine of 2 pi over 2 plus j times sine of 2 pi over 2. So we can simplify this. This would be 25 times cosine of 2 pi over 2 is just cosine of pi, which is actually just -1, plus j times sine of 2 pi over 2, sine of pi is 0, so this is 0. So basically this is going to be negative 25, and that is our final answer. And really, if you just looked at this original problem, even without doing all these steps, we know that j is equal to square root of negative 1. So if we took j squared, this would basically be square root of negative 1 squared, which is negative 1. And if we squared the 25 or the 5 in front of it, it would be 25 times j squared, which equals negative 25. So this matches up with our answer, which we used Euler's equation to solve.